Now today we shall discuss the versatile instrument, and that is named as potentiometer. Now see, whenever you want to find out the electromotive force of the cell, then if you join, say for example you have a battery, okay, and if you join a voltmeter across the two terminals of the battery, then try to understand, this voltmeter will measure the terminal voltage. So what is the use of this voltmeter? What does it do? It will measure the terminal voltage. It is not going to measure the electromotive force, because we have last time or in many different lectures we have studied V is equal to epsilon minus IR, or electromotive force minus I into R. Now whenever this kind of connection is made, some current will flow and IR amount of energy will be utilized, or there will be some loss of potential drop across the two terminals of the battery, because there is internal resistance small r, and epsilon minus IR. So electromotive force is E, but IR amount of potential drop will be there between the two terminals of the battery when current I flows. So this instrument voltmeter will measure terminal voltage V is equal to E minus IR. It will not measure E. So now if you want to measure this E, then either R must be equal to 0 or I must be equal to 0. Either I must be 0 or R must be 0. Now see, R cannot be made 0 because it is the chemical which is filled within the cell, and the internal resistance can't be made 0. So our aim is to make I equal to 0. Okay? Now see, to achieve this condition, that is I we want to make 0, okay, this instrument potentiometer is used. That is the basic concept, that we want to determine the electromotive force of the cell, and to achieve this kind of situation, that is, say we want to make current I flowing through the cell to be made 0, this potentiometer is utilized. So it is a versatile instrument. As such, it can be used in many different purposes. Okay, it can be used as many different purposes. It is used to determine the electromotive force of the cell. It is also used to determine the internal resistance of the cell. So it has many uses like this. Now in this instrument, what is the construction? First of all, see, this AC is a very long wire. It is a long piece of wire of uniform cross-sectional area. So this is a continuous wire, A to C. Say 1, 2, 3, 4, 5, 6 pieces are there, and they are connected with the help of this metal strip. Okay, or sometimes it is a continuous wire, say 1 meter, 2 meter, this way. If 6 zigzag arrangements are there, then it can be said that there is a 6 meter long wire. If 1, 2, 3, 4 arrangements are there, or 4 pieces are there, then we can say it is a 4 meter long wire. But in general, AC is a long piece of wire of uniform cross section. Okay, now this is a long wire. Try to understand, long wire, and you are joining a battery B or a cell B and a variable resistance, that is rheostat, okay, across A and C. What you are doing? You are just joining a rheostat and a battery. Okay, this is a key to put the circuit on and off. Okay, so when the switch is on, okay, then current will flow. It's simple. So current will flow through this wire, continuous wire, let us consider that current I is flowing through the wire, which can be changed with the help of this variable resistor, that is known as rheostat. We have decided that some current is flowing, that we have fixed somehow, okay, and some current is flowing, say I amount of current is flowing. So what will happen? Between this point A and C, between point A and C, what will happen? There will be a potential difference which will be produced across A and C. Some potential drop will be there across A and C. Now, let us consider that phi is the potential difference per unit length. Phi is what? Potential difference per unit length. Say for example, if you have say 4 volt potential difference total between A and C. Total 4 volt is the potential difference between point A and C. Then that total 4 volt is divided by the length of wire. Say this length of wire is 6 meter. Then 2 by 3 volt per meter will be the potential difference per unit length. What is potential difference per unit length? It is total potential between A and C divided by the length of wire AC. And that potential difference per unit length we have taken as phi. Now, this wire is uniform, okay? Then potential difference between A and any point. Now try to understand. Say for example, this point is A, and some point I am considering here, say point P, and this point P is at distance say L from A. This point P is at distance L from A. Then what will be the potential difference between A and P? What is the potential difference between A and P? You can give the answer that if potential difference per unit length is phi, if potential difference per unit length is phi, then if this length is L, then potential difference between point A and P must be equal to phi multiplied by the length. So if you want to find the potential difference between point A and P, so the potential difference between A and any point which is situated at distance L from A, that potential difference if I show by epsilon L, then that potential difference will be phi into L. This much you remember and try to understand the concept of this potentiometer. Now see, if this point is changed, if you take this point from here to here, say from that point to the other point, okay, then what will happen? The EL will change. As you are changing the value of L, you go slightly away or you come close to point A, the value of epsilon L is changed. So this device is so made that it produces variable potential difference between point A and C. It is producing variable potential difference between point A and C. Okay, now the use of the potentiometer we shall discuss in the different video. Okay, thank you.